Hello friends, today we will discuss about method modifiers. As we already studied about how to create methods, how to use access specifiers. Now today we will learn about method modifiers. So here are the topics. What are method modifiers and types of method modifiers in C#? What are static, virtual and override modifiers? What are abstract, sealed and async modifiers with example. So let's begin. First one we have method modifiers. So what is method modifiers? Method modifiers in C# are special keywords that change the behavior of a method. So mainly method modifier is like if we want to change the behavior of a method, suppose we have two methods and we want to override that first method into second method. If we want to give some new implementation to our new method, means second method, so that is the changing the behavior of that method with the modifiers. They define how and where the method can be used, such as whether it belongs to the class or an instance. So it is telling us that if we apply modifiers and we are accessing it through the class or through the instance, means directly using that instance, means we are creating the object of any class, or directly we are using that class name and then directly we are invoking that method. So here are some types of method modifiers: static, virtual, abstract, override, sealed and async modifiers. So we will see all these one by one with the example. First modifier we have, that is static. A static method belongs to the class itself, not to any specific object. So static is like if we want to use that static keyword, we can directly call that method through the class name. We do not need to initialize some object of that class and then we can use that method or call that method. We can directly call that method through the class name. You can call it using the class name without creating an instance. As I already told you that we can directly use that with the class name or with the method. It cannot access instance variables or instance methods directly, only other static members. If we want to use that, we cannot directly call these, or we do not need to create the instance of any objects. If we have static methods, static variables, we can directly use the class name and directly call that methods. Here we have the example of static modifier. Here we have main method, that is static method, and here we are calling directly with the class name. So this is the class name and this is the method name. We do not create any instance or we do not initialize any new objects of that class. So here we have this method. So let's see this one in Visual Studio. Here we have this static class and we can create here new method, parent class, first we have to create that static method with integer value and get number. Here we will provide some number and then get this number. Okay, so it will give us this number value in return in integer. So suppose if we want to use this one, first we can directly use with class name, parent class dot get numbers. Here we can provide some number and we can display this in our console.writeLine. Okay, so let's this one. So here we have the output, that is 25. we provided 5 and it multiplies this number with the same number, and we are getting the value 25. So here is the thing, in static we are directly calling this method through the class name parent class dot get number. And in the simple way, if we do not want to use this static, we can directly call this one. First we have to initialize the parent class and then we can call this method. So first thing is that if we want to initialize the objects without using the static, we can do this way. Or if we want to directly call this method through the class name, then we can use static. Okay, first let's see this one. It is also giving us the same value. Okay, but here we are initializing the class name and then calling it through the object of parent class. If we do not want to use this, we can directly initialize with the class name and with the static keywords. And here it is displaying the error because we have to inherit through the class name, that is parent class dot, this is the method name get number, and here we are passing the one parameter number. So this is the concept of static modifier. Next we have a virtual modifier. It marks a method so it can be overridden in the derived class. Suppose we created some virtual method, okay, and we want to override it, means we want some new implementation, new value, but in that, not that in same method but in new method. So we can do that with the virtual modifier, and in derived class we can override this virtual method. If a method is not marked virtual, you cannot override it. If we do not mark it as a virtual, then we cannot override this virtual method. And when a derived class overrides it, the method behavior changes based on the runtime object type. If we override that derived class or the virtual method into the new method, then it totally changes the behavior, because in the new method we applied some new logic for that, and it will give us the new output, means new value. When you want to allow customization of method behavior in subclasses, or if we want to do some customization into our subclasses not in the main class, then we can go with this approach. Here we have a virtual example. Here we create first a virtual method and then override it into the derived class, and we first initialize this object virtual derived class. Here we can see the virtual class. First we can change this name. Virtual class means parent class or base class. Okay, and here we have to change it with virtual keyword. Here we do the same thing, and next we have to create some derived class. So it is named as derived, and here we have to inherit this virtual class. So this is a child class, derived class or subclass. Here we can override this value of the virtual class. Here we can create some method of this, and this is the keyword for override. If we are overriding the same method but into the derived class, here we can use that get number, method. Here we have this one, number plus. Here we provided new implementation into our virtual class, virtual method. We are doing multiplication logic, but here in the derived class we change the logic with addition. So now it will give us the addition portion, addition value. And here is the thing, if we want to override this one, so we have to follow the method signature. Method signature means method name and method parameters should be same, otherwise it will give us the error. Suppose here I change the name. Okay, now it is giving us the compilation error because it is not finding that override virtual method. So this is the thing in virtual and override. If we want to use that or override this method, the method signature should be same, means method name should be same and also with the parameters also same. Now let's initialize this virtual class. Here we can change it to virtual and here virtual class name and then calling the get number. Okay, now let's see this one, what it will give us the output. Currently it is giving us the 25 because we are not initializing the new derived class here. If we want to get the new implementation or new derived class value, first we have to initialize this here. Here we have the base class, or here we have the new implementation, means the new derived class. Now let's see the result. Now it is calculating the addition part, means the new derived implementation, means get number with addition logic. So here is the thing, if we want to initialize the old value, then we can use like this, and it will not override it as it is using the same method with the multiplication logic. And if we want to get the new implementation with the new derived class or override method, then here we have to implement the derived class. We can also here put the derived class, it is the same thing, it will give us the same result. Okay, now we have the new implementation. But just only for clarification, we have to put here the base class, means virtual class. So this is the base class and this is the derived class with the new implementation. So now it will give us the new implementation, new method result. Next we have override modifier, used in a derived class to provide a new implementation of a virtual and abstract method from the base class. If we want to override any virtual method or any abstract method, we can use this override with the new implementation into new method. So mainly override works is that if we want to override any method, we can do it with override keyword. The overridden method must have the same signature as the base method. As I already told you that if we want to override any method, we have to follow the same signature, means method signature, means method name plus parameters should be same. When you want to change the behavior of a base class method in a derived class, if we want to implement new things or new logic into a new method, then we can go with the override keyword. We can do that things into a derived class. Here we have the example of override. Here we have this virtual method override method. We are overriding this method with this one, as we are following the method signature, means method name and parameters are same here. Speak and speak are same, and here are parameterless method, and both are parameterless method. So it is following the method signature, and here we initialize this one, and we are getting the value through the method. Here we already saw this one, override modifier, that if we want to override any method, any specific method with the virtual keyword or with abstract method, we can do it with override keyword. But the thing is that we should follow the method signature, that is method name should be same and parameters should be same. So here we are following the method signature, and here we are using virtual keyword. Now let's see this result. Here we are getting the new derived implementation, means 10 for addition as it is. So this is the thing in override keyword. Next we have abstract modifier. So what is abstract modifier? It declares a method without providing its body. If we want to use this abstract keyword, then we have to use it without a method body. We only provide the access specifier, access modifier, or any return type if we have, or the method name and the parameters, but not the logic part. So this is the thing in abstract modifier. It must be implemented in a non-abstract derived class. If we want to use this abstract keyword, we can use that into a derived class, and we can override this abstract method where we provide the new implementation with the new method body. The containing class must also be a marked abstract, and the containing class where we provide the abstract keyword, it should be marked abstract keyword on that particular method. When you want to force all derived classes to implement a method with specific behavior for each type, if we want to put some logic into our multiple classes or into our multiple derived classes, we can do it with that abstract keyword where we provide a specific logic for particular derived classes. Here we have the example of abstract. We are using abstract keyword, and we do not provide here the method body, only we provide the method name with parameters and access modifiers, access specifiers. Here we are creating the derived class, we are using override keyword, and we are overriding this same method. The thing is same in here also, we have to follow the method signature approach. And here we initialize this abstract class, and we are calling this draw method. Suppose here we want to change the virtual, and we put here abstract keyword. Now it is giving us the error because we do not need to provide here the method body, and here also we have to put this abstract keyword. Now this is the complete method of abstract. We do not provide any method body into this abstract class or into our abstract method. Next we already have derived class where we are inheriting the virtual class. We can change this name also with the abstract. Okay, now we are inheriting the abstract class here, and we are using this logic. We are using a same override. We can use override with abstract with the virtual. It totally depends on our requirement. Next we can also create some other new sub derived class. We can create multiple derived classes, and we can inherit this derived class, and we can implement new logic. But here is the thing, we have to follow this approach, means we have to follow the method signature, that should be same. Here suppose if we want to change this one, now it is instantly giving us the compilation error. So we should follow the method signature approach. Here we can change the implementation, like we can subtract this number, and here we can change the initialization, class okay. Now we have to call the methods in abstract class. Here we have to put this sub-derived class where we provide the new implementation, not in here, derived class in here. Now we are inheriting the abstract class through the second derived class, and if we want to use this one also sub-derived class, we can first initialize it with derived class. Can use this right line to display the and we have to put that get number. We can change the value here, and here we have to provide a new implementation, means third derived class here. If we want to get the new initialization, means subtraction logic. Now let's see this one. Here we are getting the value 10 for the abstract keyword, where we put the logic of addition, and we are getting 10, means we are sending 5 and then we get a 10 value. And into our second subclass we are sending 50, and we are applied subtraction logic here, and 50 minus 10 we are getting 40 value for that particular number. So this is the abstract keyword. If we want to use this one, we can use it without method body, and we can inherit into a derived class. We can override this same method with the same parameters, and then we can also create multiple derived classes where we can change the logic portion, and first we have to initialize that particular class, and then we can call that method. So this is all about the abstract keyword. So next modifier, that is sealed keyword. It prevents a method that was already overridden from being overridden again in further derived classes. Suppose we are using here the previous example, that is abstract class, where we created two derived classes, and we do not want to create a new derived class or new subclass. We want to stop this derived class logic onto that particular method. So we can put this sealed keyword onto that method, so it will not inherit further. It will stop the derived class for further new implementation. Can only be used together with override. If we want to use this sealed keyword, we can use it with override keyword. When you want to stop the inheritance chain for a method for performance or design reasons, as I already told you, if we want to stop the inheritance further into the new derived classes, we can do it with sealed keyword. Here we have the example of sealed. We are using virtual example here. With virtual we are using override keywords, and here we provide a sealed keyword. Now it is not going to override or inherit into the new class or into the new method. So for stopping the new further implementation into the new derived class, we can do it with sealed keyword. Now this method is sealed, we cannot inherit further. Here as it is, we are initializing first the sealed class, and then we are invoking this method. Suppose here we have the abstract method, and we are overriding into our two new methods. Suppose if we do not want to override further, we can put here sealed keyword. Now again it is giving us the error because we put sealed keyword, and further it will not implement it into the new derived class. Now it is giving us the compilation error, means it is giving us that that previous method is sealed, we cannot override or inherit that into a new derived class. So this is the main concept of sealed keyword. Here we can comment this one and this one also. Now let's see the output of this one. Here we are getting the addition value, that is 10, means we are sending 5, and for addition logic we are getting 10 value. And suppose here we do not provide sealed keyword here, and we want to create a new subclass. New class. Okay, now we want to inherit this into a new class with the same method name but with different logic, means new implementation. We can provide this one. Okay, so this would be the new implementation. Suppose here we provide this sealed keyword. Now the inheriting level is for only 2 derived class, not for the last derived class. So wherever we provide the sealed keyword, it will stop the inheriting further for new implementation into a new derived class. So this is the main concept of sealed keyword. Wherever we provide this, it will stop the inheriting the override keyword, means for new implementation. Next we have async modifier. So it indicates that a method run asynchronously and may contain await statements. So if we want to run the method asynchronously, so what is asynchronous and synchronous? Synchronous, already we worked on that in the previous lectures. We already created some methods that was synchronous, means suppose we have 2 methods and it will call after one, means first method if completed, then it will call that next method. But not in the case of asynchronous. If we use this async keyword into multiple methods, these methods will run in a line, in a sequence, means parallelly it will invoke at once, not waiting for first method to get the response and then next one will continue. It will parallelly start all the methods. It allows non-blocking execution while waiting for task. It is like non-blocking execution. We can use the await keyword inside that asynchronous method. An async method usually returns task or task angle brackets t value type. So asynchronous method returns 2 types, means first one is a task. Task means if we do not want to return anything, then we can use task. Task is also same as that of void, as we use that void into our synchronous method. Here we in synchronous method we use task. And if we want to return some result, means integer value, string value, any boolean value, we can use this syntax, task angle brackets value of t, means integer string. So let's see these task example. In CSharp asynchronous programming, task and task value of t are the 2 most common return types for asynchronous methods. So these are the 2 return types in asynchronous keyword. First one is task, that represents an asynchronous operation that doesn't return a value. If we do not want to return anything, we can go with task, as I already told you. And it is equivalent to void in synchronous method, and also it is equivalent to void. Suppose in synchronous method we do not want to return anything, where we use the void, and in asynchronous method we have to use this task. But it allows awaiting, exception handling and continuations. And if we want to await for that particular result to come from the database, then we can use the await keyword inside that asynchronous method. And it also handles the exceptions, and for continuation the tasks. Next, if we want to return some data through the asynchronous method, we have to go with the task value of type. It represents an asynchronous operation that returns a value of type t. We can send any type of value like integer, string, any list type we can send it. Think of it as a synchronous version of returning t from a method. The result is available via result blocking or await. We can use await keyword inside that particular method. And one thing also we have to mention here, if we want to call that particular asynchronous method, then we have to use the await keyword. Without it, it will not provide us the result. We have to use this await keyword where we are calling this asynchronous methods. And next we have 4 methods involving long running operations that shouldn't block the main thread. If we want to use asynchronous keywords or asynchronous method, and it will not block the main thread if we want to use these methods. It means if we have long running methods, means it will take time for processing, for executing the task. Then it is also a good approach if we want to use these asynchronous operations. Now let's see the asynchronous example. Here we have the async keyword, async method with the task. Here we do not want to return anything from this method, but we are delaying this task for 1 second. So here we have 1000. So it doesn't mean this is a 1000 second. It means only 1 second. So this is 1 second only, not 1000 seconds. Here we are displaying the message. After delaying for 1 second, it will execute further code. Next we simply just initialize this class and we are calling this method with await keyword. Without it, it will not give us the output. Now let's see the synchronous example. First we have to create some separate class for asynchronous calls. First we can create some method with asynchronous, and here we do not want to return anything. Here we can use some method name display age. Next we delay it for 1 second. So dot delay 1000 means only 1 second. It will wait for 1 second and then it will continue to the move to the further execution. Here we simply displaying the age here. Age. So here we are using it without returning anything. Second, we can return some data with the task. Here we can return string type, get value, and here we can delay it for 2 seconds. Means 2000. Wait for 2 seconds. Okay, now it will return some string. Okay, now we have two asynchronous method. First one we only displaying some value over here and we are delaying the task for 1 second, and in second one we are returning some data, means string value, and we are delaying this task for 2 seconds. Now first we have to initialize the asynchronous class. Synchronous class. First we have to use this, invoke this first method. And some parameters. Here we are not using any await keyword here. Now let's see first what it will give us. It is not giving us any value because we are not providing await keyword. So if we want to use this one, we have to provide await keyword, and next we have to call second method also. Value, and call this asynchronous method to get value. We have to provide await keyword for this one also if we want to get the value. Now let's see both values. As you can see, it is delaying the task for 2 seconds and first one for 1 second. So that's why it is giving us the value after 2 seconds. Here we have a first one value, that is display A, that is 30. First one value we are getting, and second value we are fetching the string value, that is developers. Here it delayed for 2 seconds for second method. So here is the thing in asynchronous methods. It will run instantly, and all the methods run in parallel at once. Here we are returning nothing, but in second method we are returning string value. And here is the thing, if we do not provide here asynchronous here, now it is giving us the error, because wherever we want to use these asynchronous methods, we have to provide async keyword with task. Without it, it will give us the compilation error, compile time error. So this is the main concept of asynchronous keyword. Next we have summary. So let's revise what we learned today. First one is method modifier, a keyword that changes a method's behavior or usage in C#. A keyword that will change the method totally, or if we provide new implementation into a derived class that really change the behavior, means we provide new logic into a second method into the derived class, that is called method modifiers, means it modify the method behavior. We have some types of modifiers, that is static, belongs to the class, not an object, called using the class name. If we want to create any static method, we have to use it by static keyword. We do not want to initialize the objects, then we can call or invoke that particular method. We can directly call it by class name. Next we have virtual, allows a method to be overridden in a derived class. Suppose we have some virtual method and we want to provide some new implementation into the new derived class, then we can do it with override keyword. So in virtual method we can replace the logic with the new one. Next we have override, replaces a base class, virtuals or abstract method in a derived class. Override is a thing, if we want to override the old method or the base class method with the new implementation, we can do it with override keyword. We can integrate this override keyword with virtual and abstract class, but into the derived class only. Abstract keyword, declares a method without implementation, must be overridden in a derived class. So abstract class is that if we want to use this one, we have to provide only method signature, means access specifier, access modifier, then method name parameters. We do not provide method body into abstract class if we want to use this one, and we can change the implementation into the next derived class with override keyword. Next we have sealed keyword, it prevents an overridden method from being further overridden in subclasses. As we already saw that if we provide 3 derived classes and we do not provide the new implementation, we want to stop this chain of inheriting the class again and again, we can provide some sealed keyword into that particular derived class, and it also works with override keyword, that sealed keyword. Next we have asynchronous keyword, it enables a method to run asynchronously, often with the await keyword. If we want to run multiple methods at once or in parallelly, then we can use asynchronous keyword. In asynchronous we can provide task or task value of type. If we want to return anything or we do not want to return something from that particular method, then we can use task, or for it is like a void, as we already saw into our synchronous method we put void for synchronous method, but in asynchronous we have to provide task. And if we want to return something like integer string value, we can put value of type with task, and we have to use that await keyword inside that asynchronous method. And where we want to call these asynchronous methods, we have to provide await keyword while calling this particular method, because without await keyword it will not give us the output. So these are the topics we studied today. You can implement or practice these all into your Visual Studio. If you have any doubts related with these topics, you can mention them into the comment section. So let's wind up today's session. Thanks. See you in the next video.